Right now, somewhere in the darkness of space, a mountain-sized rock is hurtling toward Earth at 38,000 miles per hour. And the scary part? We probably don't know it yet. The universe is not a safe neighborhood. For billions of years, asteroids have been slamming into planets without warning. They wiped out the dinosaurs. They've reshaped continents. And here's the thing, governments don't love broadcasting on the evening news. It's not a matter of if it happens again. It's a matter of when. But unlike every creature that came before us, we actually have a plan. An audacious, jaw-dropping, genuinely real plan to fight back. So let's talk about it. The threat is more real than you think. Most people imagine asteroid threats as something out of a summer blockbuster. Hollywood stuff. But on February 15, 2013, the people of Chelyabinsk, Russia, found out the hard way that this is absolutely not fiction. A house-sized asteroid, nobody saw it coming because it was traveling from the direction of the sun, slammed into Earth's atmosphere at 11 miles per second and exploded 14 miles above the ground. The blast released energy equivalent to 440,000 tons of TNT. It blew out windows across more than 200 square miles. Over 1,600 people were injured. And here's the kicker. That was a small one, just about 65 feet wide. Now imagine something bigger, much bigger. Asteroid Apophis, nicknamed God of Destruction, is roughly 1,100 feet across and weighs an estimated 61 billion pounds. Scientists initially calculated a 2.7% chance of it smashing into Earth on April 13, 2029. That might sound small, but in asteroid terms, that was the highest threat rating ever assigned to a space rock. If Apophis hit a city, it would collapse most steel-framed buildings within 9 miles. It would flatten everything within a 25-mile radius, an area roughly the size of the entire state of Delaware. Gone. In an instant. And the energy released? Equivalent to 1,200 megatons of TNT, more than all of Earth's nuclear weapons combined. Scientists have since ruled out the 2029 impact for Apophis. But here's what keeps planetary defense experts up at night. There are currently thousands of near-Earth objects we're still tracking, and roughly 10% of new objects spotted each night are ones we've never seen before. We were almost blind, and we're fixing it. For most of human history, we were as defenseless as the dinosaurs. We had no warning systems, no detection networks, and absolutely no plan. That changed in 1998 when NASA launched its Near-Earth Object Observations program. Since then, scientists have identified over 95% of known near-Earth objects, and right now, roughly 1,500 new ones are discovered every single year. Today, NASA operates what's called the Planetary Defense Coordination Office, or PDCO, established in 2016. Think of it as Earth's early warning system. It supervises all asteroid tracking surveys, coordinates with FEMA, the Department of Defense, and international partners, and issues official warnings when something worrying is identified. Every night, the International Astronomical Union's Minor Planet Center receives around 100,000 individual asteroid observations. Every single night. One of their star weapons is ATLAS, the Asteroid Terrestrial Impact Last Alert System. Run out of the University of Hawaii, ATLAS is now capable of scanning the entire dark sky every 24 hours, hunting for objects that could be heading straight at us. It's already discovered more than 700 near-Earth asteroids. But detection is just the first step. Knowing a killer rock is coming is meaningless if you can't do anything about it. So, what's the actual plan? Plan A, ram it. The most tested, most proven, and most dramatic method is also the most straightforward. You slam a spacecraft directly into the asteroid and knock it off course. No explosions, no drama, just pure physics. It's called a kinetic impactor, and on September 26, 2022, NASA did something that had never been done in all of human history. They launched a spacecraft called DART, the Double Asteroid Redirection Test, on a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California. For 10 months, the van-sized spacecraft traveled through space. Then, moving at roughly 14,000 miles per hour, it slammed headfirst into a 525-foot-wide asteroid moonlet called Dimorphos, part of the Didymos binary asteroid system, about 7 million miles from Earth. The whole mission cost $324.5 million, making it one of NASA's most cost-effective planetary defense missions ever. What happened next shocked everyone. Scientists expected the impact to shift Dimorphos's orbital period by about 10 minutes. The actual result? It changed the orbit by 33 minutes, more than 3 times the minimum success threshold. How? Because when DART hit, it didn't just push the asteroid. It kicked up enormous plumes of rocky debris called ejecta, and that material flying off into space acted like a jet thruster, multiplying the push. Scientists calculated the momentum transferred was 3.6 times greater than if the spacecraft had simply been absorbed. The recoil from the debris cloud did more work than the impact itself. This was Earth's first successful test of asteroid deflection technology. It proved we can send a spacecraft millions of miles and hit something the size of a football stadium. That is not science fiction. That is science fact. But what if we don't have enough time? Here's the problem with kinetic impactors. They require years, ideally decades, of lead time. The earlier you nudge an asteroid, even by a fraction of a millimeter per second, the bigger the deflection becomes over time. A tiny push applied 10 years out can move an asteroid thousands of miles off course. The same push applied 1 year out barely makes a dent. So what happens if we spot a big one late? What if we only have a few years, or even a few months? That's where things get controversial and real, because scientists are seriously discussing nuclear deflection. This isn't the nuke the asteroid and blow it up scenario from the movies. That would almost certainly make things worse. You'd go from one giant asteroid to thousands of radioactive fragments all still heading toward Earth. No, the actual concept is something called a standoff nuclear detonation. You detonate a nuclear device at a precise distance from the asteroid's surface, not touching it. The nuclear energy vaporizes the outer layer of the rock, and as that material blasts off into space, it acts like a rocket engine, pushing the asteroid in the opposite direction. Scientists at Lawrence Livermore National Laboratory have been running simulations on exactly this scenario, and the results are striking. Physicists have shown, using real experimental data, that nuclear deflection could work on kilometer-scale asteroids, rocks so large that even dozens of kinetic impactors couldn't move them. Nuclear deflection fills the gap in planetary defense that kinetic impact cannot address, said LLNL physicist Mary Berkey. Having both options assures we can be ready to deflect any impending impact. The catch? No country has yet tested nuclear deflection in space. The logistics of assembling, launching, and detonating a nuclear device on an emergency timeline would require international cooperation unlike anything humanity has ever attempted. Plan C. Play gravity games. What if the asteroid is still years away, but a kinetic impactor isn't practical and nuclear feels too risky? Enter the gravity tractor. And yes, it sounds like something a physicist would dream up after too much coffee. Here's how it works. You park a massive spacecraft near the asteroid, not touching it, just hovering nearby. The spacecraft's own gravitational pull creates a tiny but constant tug on the asteroid. Over months and years, that invisible gravitational leash slowly bends the asteroid's path. No explosions, no contact, no risk of accidentally breaking the rock into fragments. It's the most precise deflection method ever conceived. The key advantage? You don't need to know anything about the asteroid's internal composition. Rock, metal, loose rubble pile? Doesn't matter. Gravity pulls on all mass equally. The trade-off is time. You need years of continuous operation to pull this off. But for a moderately sized asteroid spotted a decade or more in advance, it could be the cleanest, most controlled solution we have. The world is actually rehearsing this. Here's something genuinely reassuring that doesn't get nearly enough coverage. The global community has been quietly rehearsing for a real asteroid emergency for years. In 2025, the International Academy of Astronautics held its Planetary Defense Conference, a full-scale simulation exercise involving space agencies from around the world. NASA, the European Space Agency, and the Space Mission Planning Advisory Group ran drills based on a hypothetical asteroid projected to impact Earth in 2041. Teams evaluated kinetic impactors, nuclear explosive missions, and ion beam deflection, working out timelines, launch windows, and public communication strategies. The European Space Agency is also building a follow-up mission to DART called Hera, which will return to the Dimorphos asteroid to study the aftermath of the impact in extraordinary detail, measuring the crater, the debris field, and the precise mass of the asteroid to calibrate deflection models for future missions. Meanwhile, NASA's NEO Surveyor, an infrared space telescope, purpose-built to find hidden asteroids approaching from the daytime sky, where current telescopes are completely blind, is in active development. China has also entered the planetary defense game, announcing its own deflection test mission as part of its national space defense initiative. The bottom line? Planetary defense is no longer the territory of science fiction writers and doomsday preppers. It is an active, funded, globally coordinated field of real science. If this blew your mind, smash that like button. It takes 1 second and it helps more people find content like this. Share this with someone who still thinks asteroid defense is just a movie plot. And if you're not subscribed yet, what are you waiting for? We cover the real science behind the biggest threats and breakthroughs happening on this planet and beyond it. Hit subscribe and turn on notifications, because the next video is going to be just as wild.